So I'm going to correct the homework given last week. So here you have to find the correct statement for this reaction. So you can see that this is positive, so it is an endothermic reaction, so temperature is decreasing. So these two options are correct. Now, if you look at the energy level diagram, because it's endothermic, it's absorbing energy from the surroundings, so products are at higher level than the reactants. So products have higher enthalpy than reactants, and the one that is lower is more stable. So products are less stable than reactants. So answer is C. Check your answers for page 17. Now here, this is an exothermic reaction, temperature is going up, and if you look at the energy level diagram for an exothermic reaction, so energy is given to the surrounding, therefore energy level of products is less than energy level of reactants. So reactants are less stable means higher, whatever is higher is less stable, whatever is lower is more stable. And reaction is exothermic. Answer is D. Here, you have to look at both endo and exo. And I have represented activation energy of forward reaction in green and activation energy of reverse reaction in pink. So in an exothermic reaction, you see that the activation energy of the reverse reaction. In the reverse reaction, the product becomes the reactant and the reactant becomes the product. So for the reverse, activation energy is more than activation energy for the forward reaction. And in an endothermic reaction, activation energy of reverse meaning going from product to reactant, this is less. The pink one is less than the green one. So answer is D, where an exothermic reversible reaction, activation energy of forward is greater than activation energy of the reverse reaction. Number 4, here you need to find the correct statement, and you can see here delta H is 26 kilojoule per mole. 26 kilojoule per mole means that 1 mole of iron oxide produces 26.6 kilojoules of energy. So it releases, because it's negative, so it's exothermic, so energy is released. Now, if you look at the meaning of this part here, so it means that 26.6 kilojoules is released for 1 mole of iron oxide. And if you look at the equation, 1 mole of iron oxide produces 2 moles of iron. And all answers are in the context of iron. So 1 mole of iron. So 2 moles of ions come from 1 mole of iron oxide according to the equation. So ratio is 2:1. So this is what I'm using, 2:1. Therefore, 1 mole of iron. I'm taking 1 mole of iron because all the answers are in the form of 1 mole of iron. So 1 mole of iron will come from half mole of iron oxide. But 1 mole of iron oxide produces 26.6 kilojoules of energy. Therefore, 1 mole of iron will release half of this energy. So 13.3 kilojoules of energy will be released to produce 1 mole of iron. So it is answer A. Number 5. In which reaction do reactants have lower energy than products? So reactants have lower energy than products. It is an endothermic reaction. So endothermic reaction means that it is bond breaking. Bond breaking is involved. Let's look at each equation. First one, you can see it's reacting with oxygen. Reacting with oxygen is just a combustion reaction. So burning is combustion and combustion is exothermic. So answer A is exothermic. If you look at answer C, you can see that Na plus combining with Cl minus. So this is bond formation. So bond formation is exothermic. Here, this is a neutralization reaction. Neutralization reactions are exothermic in nature. So we are left with answer B, where you have HBr forming HNBr. So here you have bond breaking. So bond breaking, this is endothermic. And endothermic reactants have lower energy than products. Answer is B.